Hello guys, how are you today? So today I'm going to be explaining section 5.2 of the course practice for the math. So I'm going to start with the first question. It says, given the integral I is equal to the integration from 1 to 0 of 6 times 2x plus 1 squared dx, applying the substitution method gives us this answer. What do they mean by the substitution method? First of all, what we notice is that they changed it from dx into what? Into du. So how do we change from dx into du? What you should know is that dx is equal to du over u prime. And in this scenario, what would be the value of u? You would go to wherever you have a complex polynomial with an exponent, and you will change this complex polynomial into what? Into u. So now it becomes integration from 0 to 1, 6u to the power of 2 dx. Now I need to take the derivative of u. How do I take the derivative of u? It will be very simply 2. So now it will look like this: integration from b to a, because we don't know what it is, 6 times u squared times du over 2. This and this cancel, and you'll be left with 3 times what? 3 over what? 3 times u squared times du, where u is equal to what? U is equal to 2x plus 1, and du, let me go down a bit here, as you can see. There you go. Du is equal to 2 dx, because we said that dx is equal to du over u prime. We know that u prime is 2. So that means what? That means du is equal to 2 dx. That is it for the first part. For part B and C, they want us to find the values of A and B. How do we find the values of A and B? As you can see, A and B are not going to be 1 and 0. They're going to be the values of new limits. Now, how do we find the value of the new limits? So B and A, they are what? They are new limits. How do we find the values of these new limits? Very simple. You take u. What is u? U is equal to 2x plus 1. And then every time we have x, what are you going to do? You're going to substitute it by what? You're going to substitute it by the original limits. What does that mean? That means first I'm going to start with 2 times 0 plus 1. I will get this to be what? I will get this to be 1. So 1 is what? 1 is my lower limit. So A is equal to 1. And then 2 times 1, which is the original higher limit, plus 1. This will give me an answer of 3. So B is equal to 3. So this is how I find the value of my new limits. A is equal to 1. B is equal to 3. Now, part D, they said use parts A, B, and C to solve for I. How can I solve for I knowing that I have A, B, and C? Very simply, it's going to be B. We found the value of B, which is 3. A was 1. And then it's 3u squared du. What do you need to do now? You just need to integrate and substitute the values. That's all you need to do, right? So once you integrate this, what are you going to get? Here, this is 3u squared. Let's integrate it. So this is going to be n plus 1 over n plus 1. So this becomes 3u, 3 over 3. This and this cancel. So now you're left with what? With u to the power of 3 du. You can remove du. So now this is what? This is, you're going to replace from 3 to 1. Right? From 1 to 3, you're going to replace it in u to the power of 3, and you're going to subtract them. So it's going to be 3 to the power of 3 minus 1 to the power of 3. So 27 minus 1 will give me an answer, which is what? Which is 26. And this answer is what? Is my answer over here. I'm going to now move on to question number 2. What does it say in question number 2? What is the value of this integral? Very simply, this is a definite integral. Anytime we have a definite integral, remember, we do not put plus c. We solve it regularly. So what am I going to do in this scenario? I'm going to solve it as a regular integral, but I don't put plus c. Instead, what am I going to do? I'm going to substitute these values. So we need to find the integral of this minus this. Let's start. N plus 1 over n plus 1. Here, n plus 1 over n plus 1. So this becomes x to the power of 4 over 4, right? Minus 5, because this becomes 15 over 3. This is now 5x to the power of 3. You don't need to put plus c. If you put plus c, in the written part, always put plus c. But on the computer, there's no need to put plus c. So if you have plus c, or you don't have plus c while solving on the calculator, it's gonna be the same, okay? So now what are you gonna do? You're gonna substitute 2 and minus 2 over here. So now it becomes 2 to the power of 4 over 4 minus 5 times 2 to the power of 3. All of it subtracted from what? All of it subtracted from minus 2 to the power of 4 over 4 minus 5 times minus 2 to the power of 3. So you put this on your calculator and you're supposed to get here minus 36 minus 44. You combine them together and you will get an answer which is minus 80. We'll now move on to question number 3. What does it say in question number 3? Okay, what is the value of these? I'm going to solve them regularly in case they came in the written part. So we need to do the regular integration. Let's do the regular integration of this. X squared minus 2x. But because they are definite integrals, we will not put plus c, okay? So here I'm going to add 1. Okay, so it's going to be n plus 1 over n plus 1. So here it's going to be n plus 1 over n plus 1. So now what does it become? It becomes x over 3. So x3 over 3 minus x to the power of 2. Okay, now what do? I substitute 1 and minus 2. So it becomes 1 to the power of 3 over 3 minus 1 squared. All of it minus what? Minus 2 times, sorry, minus 2, my bad, minus 2 to the power of 3 over 3 minus 2 squared. So you can put it on your calculator. 1 to the power of 3 over 3 minus 1 squared. Okay, minus 2 to the power of 3 over 3 minus, don't forget the brackets. They're the most important part of the equation. They can ruin the whole equation if you don't put them correctly, and you will get an answer, which is what? You'll get an answer, which is 6. We move on to part B. What does it say in part B? What is the value of the integration of 6 over x squared plus 1? So let's do the regular integration. 6 over x squared plus 1. Okay, do regular integration, move this up. So now you do n plus 1 over n plus 1. And here this is x to the power of 0. So n plus 1 over n plus 1. So what happens? This becomes 6x to the power of minus 1 over minus 1 plus x. Okay, so now what do you need to do? The only thing you need to do is you need to substitute x with 3 and 2. So now it's 6 times 3 to the power of minus 1 over minus 1 plus 3. All of it subtracted from 6 times 2 to the power of minus 1 over minus 1 plus 2. So let's try it on the calculator. 6 times 3 to the power of minus 1 over minus 1 plus 3, right? My answer, minus what? Minus 6 times 2 to the power of minus 1 over minus 1 plus 2. And I will get what? I will get my answer to be what? To be 2. We'll move on now, finally, to question number 4. What does it say in question number 4? Okay, this is a really important part. This tells us about some of the rules when it comes to integration and integrals, okay? So let's start with part A. What is the value of integration from 1 to 0, 3 fx dx? When you look at this, don't be scared. If it comes in the written part, look what you're going to do. You're going to take this 3 outside. First step you do is you take it outside. So now it looks like this. And what do? You do 3 multiplied by what? Multiplied by this, because this is integration from 0 to 1 of fx dx. And what is it? It is minus 4. So 3 times minus 4, so give me an answer, which is minus 12. Now, this is important. What is the value of 4 to 0 fx dx? Look what I have. I have integration 4 to 0 over here. I have fx dx over here with 4. So what am I going to do now? It's not going to work out for me, so I'm going to look to this one that's left over here. I see it's integration from 1 to 0 of x dx. You never choose anything that has a different function. This has a different function. I will not talk to it. I will leave it aside, okay? So now I'm going to deal with both of them that have the same function. Always, they should have what? They should have the same exact function. Now, what I am looking for is integration from 4 to 0 fx dx, right? Now, I'm going to make it equal to what? I'm going to make it equal to the integration from 0 to 1 of fx dx, right? Plus the integration from 4 to 1 of fx dx. What does this give me? What does this help me with? What I know is that if I have my numbers being on opposite sides of the limit, right? So here it's the maximum limit, here it's the minimum limit, right? Here it's my boundaries, different sides. I can do what? I can cancel them out. So now I'll combine my integration, and what will I be left with? I'll be left with integration from 0 to 4 of fx dx. Okay, just like that. Perfect. And from this, I'll be able to do what? I'll be able to find its value. So what is the integration of 0 to 1 of fx dx? It's minus 4, so that's going to be minus 4 plus the integration of 4 to 1 of fx dx, or sorry, 1 to 4, that's going to be 7, so I will get my answer, which is what? I'll get my answer, which is 3. Now part C, last but not least, what's the value of integration from 4 to 0, 9 times fx minus 2 times g? Okay, this is like, I need to zoom out a bit to get the equation. All I need to do is what? All I need to do is integration 0, 4, okay? I have 9 because I took it outside, or first of all, before I do anything, let me separate them. 9 fx dx minus integration 0, 4 to gx dx, right? Now what am I going to do? I'm going to take out the 9. 9 integration from 0 to 4 of fx dx minus integration, 2, you take out the 2, my bad, minus 2 integration 0 times 4 gx dx, okay? So now what am I going to do? I'm going to replace them. This I can replace it by 3. I found it in the previous part. This I can replace it by 5. So now it's 9 times 3, which is 27, minus 2 times 5, which is 10, which will give me an answer of what? Which will give me an answer of 17. So that's it for this course practice for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.